web services, we need interoperability. That's make or break for the future of web services. If they can't understand each other, it will not work. Another very important feature for wide area computing is that reliability is of very high importance. What happens if the server goes down because there is a programming error? We all know what happens. And furthermore, scalability is also a must. But let's look what we currently have. We have actually many, many tools. And now let's go to the back one, to the next slide. But unfortunately, they are all, there's no uniform tool. So let's look into a little bit what we have. So initially, XML has data type definitions, but they only had strings as basic types. And so recently, the W3 standard committee has defined XML schemas. And XML schemas only describe types for XML, but actually they have many more features than DTDs. For example, you have structural relationships, so you can have choice groups, or you can have anonymous types. You also have, and the way it's typically supported in all the tools that we know of is by validating parsers. So this is actually just a sublanguage that we can use for programming XML. Another sublanguage for programming XML is actually XPath. XPath got its name from the path notations in Unix file systems, where you select with / you go to the containing folder, and it is only used to describe the traversal within an XML document. So the processing model is actually purely functional. You can't update something while you select a particular node in a tree, in an XML tree. But unfortunately, XPath has no type system. So you just navigate on raw, untyped trees, typically supported by interpreter and compiler. So that's also a sublanguage. This sublanguage actually looks rather different from XML schemas. Now there's a recent proposal for XQuery. XQuery is like SQL. It's a query language for semi-structured XML data. They actually defined their own syntax, not using any of the existing styles. They actually adopted the XML type system. That's, I think, very cute. But there are currently only prototypes available. So even there is a prototype from Microsoft. The prototype, once again, is untyped, so it doesn't use the type system. And furthermore, XQuery is very domain-specific. For example, you can query your database or your document, but you can't update it. So I think we will see more development over here. Then there's XSLT. It's a transformation language. So you get one XML document, and you probably produce another one. So the programming paradigm is once again functional. Unfortunately, XSLT has no type system. So very often you actually generate illegal, not valid XML documents. And once again, this is domain-specific. But what we see over here is that all these domain-specific languages, they, for example, don't have any module system. They rarely have type systems. They have no libraries. Two other approaches that we also saw in the literature is XDuce and XLambda. They were actually not intended to be real general-purpose languages, but they wanted to stretch the limits of the type system. So you can define data definitions, but the programming paradigm is once again functional. Okay, so that's special-purpose languages. And then there's two approaches for general processing of XML. There's the system.xml namespace in the .NET runtime. But so it's a library. It's completely written in C#. So you can do everything that you can do with C#, but unfortunately, if you process XML, it's once again untyped. And untyped in this case also means it might not perform as fast as if it would be typed. Okay, so yet another approach is actually the XSD compiler. It also ships in the .NET distribution. And here the idea is that you translate your XML schemas into class definitions or vice versa. But unfortunately, since the type systems are very, very different, you often lose a lot of information. And very often you end up with the resulting classes or that only contain objects because the type systems are so difficult and couldn't match between these two worlds. So what we see is we have actually many, many X languages, all for different purpose, but all have their shortcomings. What we also know is actually that we have old C languages. So the old C language, with this respect, are very advanced. They typically have a standard syntax, they have a type system, they have a module system, they have a rich library. The only thing that they don't have is actually support for XML. So instead of inventing a new language every time, why not integrate XML into an existing language? In this case, let's take C#. Now, the funny thing is that if you try to do so, you figure out that it's actually not that easy because the worlds are so different. So on the one hand, yeah, these C-like languages, C#, Java, or VB, or JScript, they're all imperative and object-oriented. The most languages that exist for XML, meanwhile, are declarative. We have a very simple lexis. So an identifier, for example, is just a letter and underscore and numbers, digits, whereas for the XML languages, we have actually a very complex lexis which doesn't fit into the C# world. In the C# world, we only have global types, global named types. So you introduce a class A. You can't have a type expression that is a type A or B. Whereas in the XML world, you have actually global types like a type A, but you also have anonymous types. You can actually build a type expression. So this is actually of type A or B. Then you have very different worlds of types. In the common language runtime, you have actually two kinds of types, namely value types and reference types. So value types are always allocated on the stack and very efficient and don't have an identity. Reference types have an identity. In the XML world, you have something similar but not quite the same. You have simple types, and simple types are actually like the value types. They don't have an identity. You also have complex types, but complex types here are element types, and you can have you can have types that are either an A or a B or an A and a B. These types do not exist in the C# world. Then in this world, very often the element and the sequence consisting of one element are identified in order to simplify the processing. And since it's untyped, you always have to check at runtime whether the thing that you access is actually of the right type. Sorry, that was actually let's see. There was I started over here. So in the XML world, you identify singleton and elements, whereas in C#, an array of one element is, of course, radically different to just the contained element. Here we have subtyping based on named relationships. So you say class A extends B. Here you say, whoop, the class of, let's say, normalized strings is a subclass of the class, or is a subtype of the class of strings by just not allowing these kinds of particular strings, these strings that have a tab or a carriage return. So actually here the subtyping on XML is based on value space inclusion, for simple types. It's also based on structural equivalence, so A or B is equal to B or A. And we also find named relationships, which are exactly the ones that we also find over here. So since these two worlds are so difficult, that might be the reason why I haven't seen any solution to combine them. But the question is it really so difficult to combine them? And I wouldn't be here if the answer would be no. Of course, the answer is yes. So we propose to actually integrate XML types and values as first-class citizens into C#. And this is not a project proposal. This is a technical proposal. So I hope that somebody of you picks it up and talks to us later, and that we can probably integrate it into your project. Yeah?
In the previous slide, in addition to the set of things that you laid out, there is one thing that always confuses me, which is the issue between bounded trees and unbounded trees.
Yeah.
When I look at a data type declaration, it always describes a bounded tree, but an XML tree, I think about it as typically unbounded. Can you comment on that?
So the type system actually says, and I will come back to this in 2 or 3 slides, the type system allows you to say the sequence can be unbounded. But of course, every instance of this document is bounded.
Yes.
So it's just that...
But I'm saying that there's a distinction between an XML type and a C# type, which
okay.
says from the type description, so you know what the depth of the tree is.
Yeah. I can probably come back to that later if I show the type expression in C in this extended language. Okay. So our idea is now take this really literally and integrate the XML type system as is into C#. So that means that we should have a way to denote at least some types. Also, we want to include the schemas, but the results of a query can return a new type for which we don't have yet a schema. So we have to denote types in this extended language. We have to denote values, and of course the idea is take the standard as is. So we can denote values exactly like an XML document, and we can load, pass, transform, update, and write these values in a type-safe manner. And if there is a type error, then that means that this document is not valid. Okay, and the result is actually,
what do you mean with update? Meaning changing a value?
Yeah. I'll come back to that in 2 or 3 slides. Okay, so what's the idea of the design? So we need a bridge between 2 worlds, because of course we have strings in C#, and we want to pass them to build up XML trees. So the idea is that you actually take C# value types that they can stand in also for simple types. Not C# reference types. They can't be leaves of XML trees. So that means that our XML trees are really XML trees. They don't have links to the object world. But the object world can have links to the XML world. We inherit more or less the value types from C# for XML simple types. We add complex types with all the glory of the XML type system. And we also add one particular type that's very common in XML. That's a sequence type. And we also add iterators in order to process sequence types. And okay, let's see how that looks like. So this is the general picture in the CLR. Object is the root of the whole type system. We have reference type, value types. And now a new class of types, that's actually XML types. As I already said, reference types and value types can contain XML types. But XML types can only contain these XML simple value types. But XML types can also be complex types. So this is just a picture of what I said on the previous slide. Now let's look into more detail, and then let's just make some examples how the language actually looks like. So here is the standard schema for a little bibliography. So we have the schema, which is called, we have the schema, and which might have two roots called bib and book, respectively, that are elements. And note that in opposite to DTDs, these guys are actually typed. So that's this green color. And then our type bib is actually a complex type. Here it's a sequence that occurs minimal 0 and maximal unbounded. And we have books which have two elements, so sub-elements, title and author. And they also have attribute, and the use is either required or optional. Okay, so we need a way to express this in C#, and this is just one proposal to write the same data type, to write the same information now in C# that we have just seen in the schema. This is,
I'm a little bit worried about that you used the term group there for what was called complex type in XML schema, since XML schema has an own concept called group, which is just the structural components that you can reuse. But
semantically, you can map them onto each other. Pragmatically, they are used differently, but the formal semantics actually unifies them all together.
But
and so,
I'm currently working on the XML3 working group.
Okay.
That's one of our main issue areas here, and one of the issues that we have is that in XML schema gives validation semantics at the moment, not really type semantics. And the validation semantics makes a difference between group, which is mainly a way of giving some grouping inside the schema document, and types which have name equivalents for validation purposes. And the XQuery type system that currently maps types into structurally equivalent classes, which is different than groups as well, but it's also different than XML schema types.
So it has this approach has almost the same limitation as the current XQuery approach. It's actually it's written along XQuery as it exists today, the formal type system of XQuery. So, but I think we probably should follow up on this and discuss it after the talk. Okay, but the whole idea is also you can write it down in this extended C#. The idea is you don't have to write it down because you import schemas. And I will show you an example for that later. So just to give you an idea of the subtyping relationships that exist, for simple types, I already told you that it's actually the inclusion of value spaces. For example, this normalized strings doesn't allow certain strings. It's a subtype then of string. For complex types, it's actually the inclusions of sets of sequences that these types denote. And for example, there are actually many relationships, but if it's obvious that a type like T1 is obviously a subtype of the choice between T1 and T2. And we also saw this sequence notation. And the sequence notation is probably very important because we will see that in the following. So that actually denotes a sequence of minimal m elements and maximal n elements. And of course, if now T is a subtype of T prime, and if these indices here are in the range of the indices there, then this one is also a subtype. The former one is a subtype of the later one. Okay, so I'll skip the rest of the theory from here on and show you examples. How do you program XML in C#? Okay, this is our
question. So when you build complex types, there are certain operations which are normally done over XML.
Yeah.
You don't allow them over arbitrary types. Is that correct?
Actually, there's as long as the documents are well formed, there's also always a type for it. But it's like any object in the C# world is actually an instance of the system.object type, and any object in the XML world is actually an instance of any type. So there is a common super type for all XML, valid for all well-formed XML documents.
So you cannot take, say, 4 of arbitrary types, disjunction of arbitrary types, only for XML types.
Yeah. So this is really, it only extends C# with these XML worlds, and it lives in there, in its own world. Okay, so this is just a standard instance document. I don't have to explain a lot. So let's see how we work now with schemas and instances. So the first thing is, okay, let's just construct a value, namely a book. Okay, so the whole idea is, how do you get the concept of namespaces, of the XML namespaces, into C#? Okay, C# actually has namespaces, so we just reuse this idea of importing a namespace, but now this is actually a schema definition. And we can now just write normal literals. It's a little bit tricky with the lexis, but it works. Yeah.
Using the using construct a little bit here, given that using is not in C# what it means in Java, right? I mean, it's not like a pound include.
Yeah.
It's like just a shorthand notation for it.
Okay, so I think actually I like to discuss this a lot. This is just a proposal that we came up with, and it might be very important to tune it at certain positions in order to not to mix up the different concepts. So I tried to reuse as much of C# as is, and sometimes it's probably overdone. Okay, that might be a place. But I will show you that it actually should work nicely in the following as well. Okay, let's go one step further along. We also have actually, like in C#, we can have various namespaces. In XML, you can also have various namespaces. So you can build up literals belonging to different namespaces. And the idea is that you introduce in XML actually a prefix that you can attack then to each element or attribute that describes from which namespace to which namespace does this element or attribute belong to. So now let's reuse once again the syntax of C#. So this is now our prefix. It's exactly the prefix the way it is used currently in C#. And this is the corresponding namespace. And of course, C# currently hasn't a default, but in XML you also have default namespaces so that you don't have to write the prefix. And then you can actually say, this book comes from this namespace, in this case, Edison Wesley namespace. The problem now is, once again we have a clash between the two worlds. We haven't only the clash here with this smaller and greater signs, but we also have the clash with the normal XML convention of using colons to distinguish between a prefix and the local name of an element or attribute. Okay, so we need some quoting mechanism. Backquotes are not yet used in C#. Very pragmatic way to actually get them into the language. So it's really the problem that you have to switch between languages all the time. But I think the benefits should become clear at the end. Okay, so XML quotes. So of course we also want to have dynamic documents. That is, we want to create documents with C# expressions. For example, we want to create the same book that we have just seen by writing a procedure for it. Okay, so The blue one is actually the stuff that we wrote 2 slides ago for our particular book. But now we want to plug in the parameters that are passed to this method. Okay, the XQuery convention is actually to use curly braces. And within curly braces you can have expressions. So this book ISBN is now taken from this parameter, if you evaluate it. The title gets the title that's of the C# world, but now we have a serious problem. The next thing is actually that in XQuery you can also construct sequences and plug them in where sequences are expected. For example, here we actually expect a sequence of authors. As long as you have a functional language, that actually works fine, because then it's just an expression that produces a sequence. Here we are in an imperative world. So we have to have some way to actually construct a sequence and plug it in place. And the standard trick for this is actually to use iterators, and I will come back to that later. So here you can just think that for all the authors that are given as arguments, a sequence of authors is constructed and plugged in place where this placeholder stands. So we actually construct a sequence of authors here.
I have a few questions and comments here. I'm a little bit worried about overloading the construction syntax because, I mean, in XQuery, if that's a variable, you would have to have a $ISBN sign there and the $title sign. And then also what you're writing down there, I'm a little bit confused about what is really kind of XQuery and what is kind of your own invention. I mean, is it mixed content down there? Is it for a declarative iterator, or is it a procedural iteration?
It's a procedural. Okay. So what we wanted to do is we looked into the literature and have analyzed what approaches do exist, and then we thought we try to take whatever exists. We don't want to invent completely new languages. So we take XML schemas as are, XML instances as are, and now we go to this quoting mechanism. But there is actually only a quoting mechanism in XQuery. So that's why we adopted the quoting mechanism of XQuery. XQuery, in this particular case, has a declarative for loop. Or you can write a declarative...
It's an iterator.
Yeah, you can write an iterator. Okay, and but since we don't want to copy the declarative world of XQuery, since we are in an imperative world, we have to adapt whatever exists in the imperative world. And for the imperative world, Todd Probsting recently has suggested to add iterators to C#, and this is just one instance.
What is that yield then doing?
So this yield actually constructs a sequence. So this for loop is evaluated, and so suppose that there are actually 2 authors provided. Then it constructs a sequence of 2 author elements, and that's the result of this quote. It's like an expression, it's like a statement with an expression as a result, with a return, so to speak. It's just inlined. We will see later iterators, I think in 7 slides from here, how they are really introduced. This is just a special form, in order to do the same thing that you can do in XQuery. It just uses different syntax. The syntax adapted from C#.
Then the next question is, I'm totally confused about your curly brace alignments.
My curly what?
Your curly brace alignments.
So that might be...
I assume that the 4 is missing one.
Yeah, you just got one on the
because I kind of was aligning them differently.
You're missing a close on the
Okay.
It's fine.
Okay.
I figured out what's missing.
So that, forget about that one, and then it should be correct. Or add one.
Can I ask then the next question? So if you have imperative or procedural language embedded in there, how do you deal with side effects?
just wait a second. Okay. That's actually so currently, let's first discuss a little bit projection, and then I'll come to the update problem. Okay, so as I said, we want to take the languages mostly as is. So we took a subset of XPath, and you can now write, in order to select nodes or node sequences, you can now write get XPath in order for a particular document. For example, suppose that you have a variable bib that holds the bib database. Then you can write get bib book author. And I think how is the type checking for these expressions done? Of course, we know that bib actually had type bib, and every bib had a sequence of an unbounded sequence of books. So bib/book. This is select the children elements book of bib as then corresponding type book 0 star to star. So unbounded sequence of book. And also every book has at least one author, but since this is flattened, since the books, we can have actually 0 books. That's why the expression bib book author has actually the type, it's an element of author of string, and that can occur 0 to unbounded types. Okay, so you can actually type check with a given XSD definition XPath expression.
I have no idea what that last type means. Element of
okay.
string.
So this is one. Okay. So the author is an element in the schema, and the element contains one string. So this author element contains strings, and this just says it's like array notation. It is actually an unbounded sequence of author elements that contain strings. Yeah. So syntax is always a difficult business. Okay. Okay. So now you can just add more stuff to XPath. So XPath actually allows predicates, and within the predicates you can, with dot, you can always select the current node. For example, to find all books which appear in 2000, you can write this expression. You can also have aggregation operations. Now the sequences are just almost normal types in the C# world, and of course you can write operations on these sequences, and one of them might be last or maximum or minimum. And this is still syntactically a little bit ugly, but the idea is that you can also sort XPath expressions by a particular key or by several keys. Then you would get lexical ordering. That's actually almost all. The first two things are supported in XPath. The third one is supported in XQuery. Now coming back to updates. So, of course, we also want to update our node sequences. And so the idea is, if book is a variable of type book, then if it's a variable, then of course we should be able to update it. And so we just use the set notation, set XPath equals expression. So this XPath now selects nodes or node sequences whose content is updated. And this is the way you would propose to write an update on book attribute. And note that the slash is normally used as division, but since we use these XPath expressions only as argument to set and get, we always know in which lexical context we are.
Wolfram?
Yeah?
I've always hated XPath because it doesn't look anything like XML.
Yeah.
It's this thing meant to describe XML that came from a completely different universe.
Yeah.
Now you've got this language design in which you've introduced XML syntax for the construction of these things. So in other words, XML now represents XML, which seems to me to be self-evident good.
Yeah.
But now to update them, we're updating something that doesn't look anything like the XML anymore.
Okay.
Why the disparity between the two?
The path that doesn't.
Well, yes, it's just the path.
But you're not proposing that you describe the paths using XML notation, are you?
Yeah, I am actually.
Okay, can probably shortly answer this and then come to the next question. So the reason was that XPath seems to be accepted in the XML community. So, for example, it's even used within XML schemas if you describe unique attributes or so constraints on your XML document, where you have to link certain parts in your document. Then even in XML schemas, you meanwhile see XPath expressions. So if you learn XML schemas, you actually have to learn XPath expressions. And so that's why we didn't want to invent something new, but just take what exists.
They've got their foot in the door with this hideous thing.
So to speak. So we inherit bad syntax in the sense. Okay.
Well, I have another question here. One is, what you're doing here is you have a very simplistic value assignment update language, and if you look at the Yukon spec for XML DML, which data manipulation language, modification language, there is a whole set of update statements that we integrate with XQuery, and of course for setting updates we have something similar. The only thing is that the syntax looks a little bit different, a little bit more complex because it can move more. So, did you look at any of that stuff? Or?
Actually, I went to the W3 website and searched for update syntax and semantics. I didn't find anything. That's why
I would recommend that you talk to the representatives to the W3C and then you get the information.
Great. So we should definitely talk afterward. Okay. But of course, so we went this path and just to see whether we can use get and set and play with it a little bit. And of course, you also want to reuse the node that you have selected in order, for example, in this particular case, to update the book title to uppercase. And the way that's typically done in C# is in the context of properties that there is an identifier called value which always holds what is currently updated. So we just took this idea and transferred it into the XML world. So that is value stands for reuse of nodes. You can also update multiple ones because this actually author list can represent several nodes that are selected. And of course, you also want to say that you want to insert something before or after, or that you want to delete something. Okay, so syntax. Probably a matter of question.
Well, there's also semantical issues.
Yeah.
Slide before we said set book /at attribute equals a value. Which means you replace the value of the attribute. In this case, you're not going to replace the value of the title, but you're going to actually replace the title with a new node. And that is and using the same syntax to express that will give you lots of semantic headaches.
Okay. So so your observation is completely correct, and that's currently done by intention. The reason is that typically with elements you have, for example, attributes that you also want to manipulate probably in a single chunk, and that's why the update semantics for attributes and elements is slightly different. It's just that we thought that this would be the most natural way. Okay, but that's not your...
That's not my experience. I mean, having designed an update language for based on with integration with XQuery, the problem is that people first they want to see their verbs describe more what is actually going on. So just saying set for insert updates and everything else is a little bit is not helpful for them. The second point is that originally we had, for example, updates or replace, doing both replacing values of nodes, replacing the nodes themselves, and people were getting confused when what was happening.
Okay.
And people want to, normally they have properties such as attributes and simple typed elements that they want to replace the value with. So in this case, if title is of type XSD string, then they don't want to go and replace a new title element, because in the X-query data model, you actually have you have actually what is called a node ID for each node. And in this statement, what you're going to do is you drop an element and recreate a new element, which is too much effort. It is a big performance impact. It actually creates, the construction there creates you a new element with a new node ID, and you then go and replace the old one with, which is something that people may not want to have happen as a side effect of just going and update the value of the element.
Okay, so that needs refinement.
Yes, and definitely.
Okay. Okay. Now let's. XML values are still values, so we can't update them if we just pass a book into a method. We can't just update this particular book. And the way we deal with it, that we say, since it's a value, you can actually update parts of the variables containing XML values, but then you have to pass the parameter by reference. And so that uses just the same concept that exists for C# value types, for example. Okay. Of course, you also want to have, sometimes you want to iterate over various databases. And the nice thing is actually that C# already provides iteration in the form of a for each statement. But typically you see here for each in, and then a type that actually exposes an enumerator interface. But we often want to, so in XQuery, you often want to not iterate. You want to concurrently iterate over several documents in order to compare them or aggregate new information. So the idea is, in order to simplify the translation, we just allow now to have a sequence of variables in this for each statement. And this is just an example. Select from two databases all books that have overlapping authors but different titles. And so these are just the XPath, corresponding XPath expressions, where the final XPath has actually a predicate associated with it. Okay, and of course, since we have an ordering relation on XML documents, we actually, this for each loop actually would preserve the order. So the binding that occur is actually, so A2 iterates faster than A1, iterates faster than B2, iterates faster than B1. But often you are not interested in maintaining the order, and actually there is a missing token here. You can actually write for each unordered, and then the order relation, the ordering of the bindings is not maintained. And that's very similar to XQuery. Okay, you can also read and write XML documents.
Wolfram?
Yeah.
In the previous example,
Yeah.
the sequence.
Yeah.
Unordered.
Unordered, yeah. Oops.
Can
This one. So there is actually another keyword, unordered, over here. So
right. Can you allow repetitions?
Unordered still means it has repetitions.
So it's multi-set.
Yeah. Okay. Okay, so nothing special about that. The only thing is that reading and writing is type safe, and I will show you this. And the way it is intended to be used is that you actually just use the variables, and you can think about that assignment is actually a property that then inspects whether bipout is actually a file or a variable and either writes to the file or updates the variable. The interesting question here is, so this example should actually do the following. It should take a BIP file and strip, I think, the price here, strip the price of this BIP file and write it onto bipout. So you open the two files for reading, writing, you calculate the new BIP entry, and you close it. But this looks as if it's painfully slow, because it looks as if we first read in the whole BIP file, create a new BIP instance, and then write it out. So can we make that faster? And
can I ask?
Yeah.
I have a question here. You're saying it's type safe.
Yeah.
What does that mean? I mean, because the problem that I see is that if I have an XML document which is valid according to bip.xst, not type valid.
Yeah.
And if I do updates, then I would assume that users expect actually to get the validity constraints checked as well, not just the type constraints.
Yeah. So that's actually true. There is an additional, I think there was once a short note. You have to do additional runtime checks. So it's not, everything is not compile time checkable. But the runtime checks are generated with the code. Okay, so the idea is, how can we make this function that constructs the new book list, how can we make that faster? And the idea is, okay, this is just an iterator that you can call for example, in a for each loop, and then it always, with calls to move next, it always gets the next value. And Todd Probsting has recently proposed this for C#. The only thing that's actually different from his proposal and our proposal is that we actually allow arbitrary type expressions as results over here, so that you can actually say you yield a book, and after that you yield an author or something like that. Okay, I think that's almost it. Generated a lot of questions, but that's the intention of today's talk. So what we wanted to do is we wanted to show that you can actually integrate XML into C# in one way or the other, but the best thing is really to take XML values as first-class citizens. If you do so, and you nevertheless have a small problem, that actually the XML values should live in a separate value space, because they behave slightly differently than the normal C# values. But otherwise, you can support them as are. In opposite to XQuery, which has, for example, no module system, you get everything that you have in C#. For example, also versioning for your programs. But since we took C# as an underlying language, it's all expressed in an imperative setting, which sometimes is not as nice as in a declarative setting. But I think we have shown that there is a reasonable solution for that as well. And the iterators actually allow you to process XML document fragments piece by piece. And that's very important for all stream processing transformations. But of course, it's only a start to actually get more of XSLT into the language, if that's useful at all. There is a, first, thanks for coming. Of course, I'm open to discuss everything, and Eric is also very interested in your comments. There is actually a paper on this proposal. Unfortunately, you have to wait an hour or so until I update it, because that's actually an old proposal, and I had to prepare the slides. It was a little bit fast this morning. Okay, questions?
Something worries me. Suppose you say for each,
and
you go through XML sequence, and what you do involves another SQL, which can scrap the sequence. So there should be some kind of safety. If you go to XML, some kind of a lock, then you better lock this XML structure. Does it make sense?
Yeah. It's already, it's not really encompassed so far, but a little bit is actually there. The idea is that you would play more with the kind of effect systems. So a very simple way of an effect system is actually already in C#, that you say during that you can actually qualify variables as being read-only, and so this idea should be extended in this context as well. Okay.
Can you go quickly back to your...
Yeah.
Yeah.
Absolutely, yes.
You're supporting full XSD semantics as a goal. How are you going to deal with reflection of types, specifically like annotations?
Okay, good question.
You broadcast it?
Good question. Typically, yeah. Okay, so the question was that we want to support the whole XSD, everything of XSD, and XSD has. Okay, can you probably say it again?
The XSD allows annotations to be decorated over the type space, and how would we reflect these annotations, for example, missing facets in the underlying space, into a static type system like C#? Is there a reflection API or something like that?
So the intention is that there is one, but currently we haven't done anything on that. Okay. Yep.
Have you considered integrating any of your sequence stuff with like the existing C# collection APIs? I mean, it seems there ought to be coercions in and out.
Yeah, right. So there are actually coercions of these singleton sequences to their elements, and implicit coercions, and vice versa, and of arrays to sequences, and vice versa. The problem is that arrays, so we took the C# as it exists today, and today we only have one generic data type, and that's array of T. If we would have if we would have generics, then actually much of the work could be smoothened, the integration could be smoothened. And that's why we currently decided, okay, to have actually arrays, and now a new generic sequence type named sequence, and have conversions back and forth. So it's a shortcoming of the current design.
Right, so right now you have some limited set of coercions in and out of, because what you have otherwise is array of T, or essentially you have array list of objects.
Yeah, exactly.
That's all you have.
Yeah.
You mentioned briefly at the beginning the fact that XSD has derivation by restriction, not just by subclassing. And the key point there obviously is that you can restrict the type based on a facet, but you can't really, there's no type checking that you can do statically on an instance that comes in as you can with a type language like C#.
Yeah.
How is that going to feel like to the programming language?
Okay. So there are actually two kinds of restriction. A restriction on simple types, where you actually restrict the facets, and restriction actually also on complex types, which is almost like another named relationships, because this restriction you can only erase certain fields that you have in the base type. Okay, restriction in simple types is actually supported via the value types. So what we do is we generate for each simple type that has a restriction, a structure in C#, which constructor checks the restriction at one time.
So, for example, are all these things completely divergent? That is, if I have a strict, like an integer that has a precision of 10 digits, and an integer that has a precision of 5 digits, will the 5-digit one be can be used as a subclass of 10-digit one?
No. So for the simple types, we actually took the C# types. So we adapted the C# system to have a common bridge or common language. And so there in C# you actually can't have these subtype relations by subset inclusion. What we do is we generate implicit converters. And implicit converters are applied if, for example, you have your integer with 5 digits and an integer with 10 digits. And so the implicit conversion would actually take the integer with 5 digits, make it an integer, and then you would have to call an additional constructor to make the 10-digit.
And how would you, I mean, you're saying that you automatically generate all these converters just by looking at all the schema and figuring out essentially which ones of these would have some kind of natural conversion.
So in the same area with respect to derivation by extension and restriction, one thing that we realized when we were working on defining the type system for XQuery is that it doesn't really easily map down into what you know from object-oriented programming languages in terms of subtyping.
Yeah.
So the current proposal is actually based on a union approach.
Yeah.
That every supertype is a union of all the potential subtypes that you have specified, so that you can actually define subtyping based on structural subsumption. How did you address that issue?
So that would goes back to the group problem. So we would actually express it as a group, and then have a choice as a choice group of all the different subtypes to get the same. Yeah, it's the same. Actually, it's adapted for us.
The obvious facetious question, which you don't have the answer, is why isn't that documented in XML?
Because I want to read it.
Perfectly real.
An XML import.
Any more questions? Otherwise. Thanks a lot for coming. And we like to get your comments, so feel free, read it, and send us email, invite us for further discussions.